Good morning, one and all. Today we are going to present regarding our research project on zero-shot machine learning. Machine learning refers to the problem of being given a model M trained on a dataset D, and given this model, we have to forget the information it has gained from a subset of the data, forget data, while retaining its performance on the retained data. A compute-intensive method would be to completely retrain the model on retained data, while machine unlearning refers to an efficient method of computing a unlearned model which performs similar to the retrained model. Zero-shot machine unlearning adds additional constraint that the forget dataset and the training retained dataset cannot be accessed. The seed paper proposes two approaches of tackling with the problem of zero-shot machine unlearning in a classification setting where we have to forget all the data points corresponding to the forget class while retain all the data points corresponding to the retain classes. Error minimization maximization noise refers to an approach in which anti-samples are those samples which have maximum loss on the forget classes, while data representatives are those samples which have minimal loss on the retained classes. By computing these samples and storing them, then finally we update the original model using these computed samples to get our retrained model. Gated knowledge transfer is an approach similar to knowledge distillation. In this, we use the already trained teacher model and learn a unlearned student model. The student model aims to minimize the KL divergence on those examples with the teacher's predictions to gain information regarding the retained class from the teacher. And it additionally uses attention to mimic the inner layers activation of the teacher. The generator is trained so that it generates those examples which maximize the KL divergence between the teacher and the student. The bandpass filter is used to restrict those images to be learned by the student which have a probability which is high predicted by the teacher for the forget class. One small shortcoming we observed of the proposed approach is that it only checks whether the teacher's probability is predicted low for the forget class, while it misses to check whether the past samples are a good representative of the training data. So we employ this additional criteria of checking whether the entropy of the teacher's prediction are low enough, denoting it would be likely a training sample. With this, we are able to much quickly achieve the retain accuracy for a given value, but the value we are able to achieve is poorer. Currently, we are carrying out experimentations to determine the reason behind the failure of this method. One more inconsistency we felt that we had noticed was that in the case of gated knowledge transfer, the student model slowly after some time start gaining accuracy on the forget class, while for the completely retrained model, the accuracy on forget class always remains zero. We realized that this was because of the attention being computed with the teacher's inner layers. This implicitly helped the student model to learn information regarding the forget class and hence gave a non-zero accuracy. We tried removing the attention, but this worsened the performance of students. We believe that this was because the generator did not generate good enough examples so that the student could learn without attention. To mitigate this issue, we explored deep inversion, which helps generate samples similar to the training data given the trained model, and we were able to generate better images. As we can see in the given slide, that deep inversion has undoubtedly performed and generated the best images out of all the three cases. Next, we compare our performance on the MNIST numbers dataset. So the paper reports the following three accuracies for the retrained model, the GKT, and the minimization maximization method. When we remove attention from the GKT, the student model is not able to cross 50% accuracy, while increasing the number of samples in deep inversion and retraining a completely new model has helped us improve the accuracy significantly. From this, First of all, we were able to learn how to tackle machine learning in general and more specific to the zero-shot setting. We were also able to reason regarding why there was a non-zero forget class accuracy for the GKT method. Finally, we were also able to improve the quality of images generated using deep inversion and get decent results. So for most of us in this group, this was our first research experience. Initially, we were afraid to read research papers, but now we are much more confident. And finally, we have got the ability to tweak different machine learning code and assemble them to generate our required model. Thank you.